when two networks or more networks are connected to connected with each other, they need this IP addresses to recognize how these computers or the devices are recognizing the other devices that are connected with that particular network from a different network, right? So for that, we are using a component called IP address. Now this IP address is divided into two categories. There are two categories of IP addresses, like two versions, right? So one is called IPv4 addresses. The other one is called IPv6. So this means Internet Protocol version 4. I'll write the name at the below. So this is Internet Protocol version 4. And the other one is Internet Protocol version 6. And these IP addresses are consist ones and zeros inside it, right? So IPv4 address is having 32 bits. 32 bits means 32 ones and zeros inside that address, and IPv6 is having 28 bits inside that address, right? So in our syllabus, we are concentrate on IPv4 addresses, not IPv6 addresses. So hereafter, if I'm saying IP address, it is regarding IPv4 address, right? So IPv6, that is something that we are not going to discuss with our syllabus, right? So IPv4 address the natural way, not natural way means the way that we can see it generally in our computers, the way we can see it generally is in this format. We call this the dotted decimal format. So it is like this: 192.168.35.42. This is called the dotted decimal notation. Right, now this dotted decimal notation, now previously I told you this IPv4 address is made out of 32 bits. Now I'll show you how this dotted decimal notation is arranged. So now these are decimal values, as the notation says, right? These are decimal values. So what they have done is they have divided the 32 bits of IP address into 4 separate parts, which means like one part consists of 8 bits. So which we call a special name as octet. I'm going to write the details. So that means a part which consists of 8 bits. So that particular 8 bits are going to represent this decimal value. So that means this 192 is going to represent in 8 bits. That means 8 ones and zeros, right? දැන් මේක කරනකොට හොඳට මතක තියාගන්න. දැන් අපිට දෙකෙන් බෙද බෙදා ඉන්නවට වඩා හරි ලේසි මේ matrix එක මම අඳින විදිහ පොඩ්ඩක් ඔයගලන්ට follow කරන්න පුළුවන් නම් විශේෂයෙන් මේ ගණන් වල. Right? So the trick I am using over here, I am writing the place values. Right? එතකොට මේ තියෙන්නේ මතකයිනේ binary values වල binary number එකක place values මේ තියෙන්නේ. Right? So 192, how we are going to represent 192? So 128 plus 64 will give you 192. So 1 1 0 0 0 0 0 and 0. It's going to represent 192. Right? Did you got this thing? How 192 is represented? මෙතන අපි මේ පාවිච්චි කරලා තියෙන්නේ binary number එකක place values 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7. Right? මම කොහොමද 192 ගත්තේ කියන එක තේරුණාද? ඔව් එක්කෙනෙක් කන්ෆර්ම් කරා අනිත් කට්ටිය දෙන්නෙක් කන්ෆර්ම් කරලා තියෙනවා අනිත් අය දැන් මේක හරියටම අල්ලගන්න මොකද IP calculations වල තියෙන්නේ මෙහෙම convert කිරීමම විතරයි. Right? කියන්නේ මේ conversion සෑහෙන තියෙනවා. කියන්නේ binary value එක ටක් ගාලා ලියා ගන්න ඕනේ අපි එක ටක් ගාලා figure out කරගන්න ඕනේ. Right? හරි. So this particular set of bits are called an octet. Right? මේකට අපි කියනවා octet එකක් කියලා. Right? So actually this is the first octet. Right? First octet. Right. So likewise, each and every dotted decimal notation or the dotted decimal value is placed or is represented. Yeah, මෙතන මේ dotted decimal notation කියලා කියන වචනේ එක්කන පොඩ්ඩක් change කරා මොකද මේ හරක අස්සට ආපු නිසා. Right? So each and every decimal value is going to represent like this. So here I'm going to represent the 168. All right, so දැන් මේ මම ලියන විදිහට මේක දිගටම ලියන්න ඕනේ නෑ ඔයගලන්ට මතක තියෙනවා නම් ටක් ගාලා එක සැරේ binary pattern එක ලියන්නයි තියෙන්නේ. So for 168 and another 40, right? So 32 plus 8 will give you 168. So I can have zeros for all other places. So this is what we call the second octet. Right? So likewise the third octet. Right, so you need 35 to be created. So I need 1 over 32 and 1 over 2 and 1 over 1. So 32 plus 3 will give you 35. So here comes the 35. So this is called the third octet. And the very last one, 42, is called the fourth octet. So 42 is made out of 32 plus 10. 10 means 8 plus 2. So here comes the 42, which is called fourth octet. Right, hari. මේක තේරුණාද? කතා කරපු දේවල් ටික තේරුණාද? Right. Okay, great. Right. So dot will be placed in between these places to show this is the representation of dotted decimal thing. Right. Then after, in a particular IP address, like it is being divided into these 4 octets, there is another way of dividing the IP address, which we call as net ID and host ID, right? So on that place, we really don't have a particular margin like the octets from where the net ID and the host ID, like not a particular fixed margin, right? Can we dot them? Octets වෙන් වෙනකොට හරියටම 8න් 8ට වෙන් වෙනවා. net ID host ID වෙන් වෙනකොට සමහර අවස්ථාවලදී හරියටම වෙන් වෙන තැනක් තියෙනවා. ඒ කියන්නේ 8න් 16න් 24න් වගේ වෙන් වෙන තැනක් තියෙනවා. සමහර වෙලාවට margin එක එහෙම යනවා. Right? So because of that, we generally say a network an IP address is having 2 parts called net ID and host ID. Right? ඒක ගැන පොඩ්ඩක් ක්ලියර් කරමු. So if you consider this as the IP address, the first part is called the net ID and the rest is called the host ID. Right? So we don't know from where this, like we don't know means like there is no fixed point to draw this margin. It differs due to the classes. අපි ඉස්සරහට කතා කරනවා classes කියන්නේ මොනවද කියන එක. Right? So generally this is the idea. So octets විදිහට වෙන් කරලා කතා කරන්නත් පුළුවන් IP address එක. net ID host ID කියලා වෙන් කරලා කතා කරන්නත් පුළුවන්. Right? So why these two things are there? The net ID determines what is the network, or like it can, using the net ID we can identify whether it is whether this IP address is in the same network or not, right? So this determines the network. Host ID determines number of hosts. determine word should be there. Number of hosts that can be connected to the network. Right? So those are the major functions that we can take from the net ID and the host ID. So like, since we don't know how many bits are there, so we can say there can be X number of bits to the net ID and there can be Y number of bits to the host ID. So X plus Y, we know it is 32 bits because that amount is not going to change. Due to the arrangement of net ID bits and host ID bits, there are several different classes which are being divided in the network field. Right? May locate in a network field එකේම IP addresses classes වලට වෙන් කරලා තියෙනවා. And then remember there is a concept called, so a classes වලට වෙන් කරලා තියෙන IP වලට අපි කියනවා class full IPs කියලා. Class එකක් තියෙන IP address එකක්. And there is a concept called classless IPs as well. Now if you consider the world, the IP addresses, the classless IP addresses are in the amount, classless IP addresses are greater than the class full IP addresses, right? You will realize why when we are doing the lesson. So let's first recognize what are the classes are. Then මම classes ටික determine කරගන්න යන වැඩේට ටිකක් ඉඩ ඕනේ, right? ඔයගොල්ලෝ ඉන්නේ කොලේ මැද නම් අලුත් කොලයක් පාවිච්චි කරන්න, ඒ වගේම A4 එකක හරස් අතට නම් වඩා ලේසි මේ වැඩේ කරගන්න, right? Horizontal side එකට. උස අතට නෙවෙයි, හරස් අතට ලේසි, right? Okay, so I'm going to give you the details about the classes, right? Classes ටික නෑ මම මේ අන්තිම පොඩි diagram එකකට පොඩි ඉඩක් ඇති. තව ඉඩ හම්බෙන එක තව චුට්ටක් පහලින් එන්නේ. මම කියනවා ඒක පටන් ගන්න වෙලාවට, right? So first let's recognize the classes. Now it is like this. So there are 5 types of classes in the network field. So it is recognized as A, B, C, D, and E. Right? So in these classes, the octets are arranged in a particular manner, right? Specifically when it comes to the class A, B, and C, right? So if I divide this into the octets, right? And I'm going to mark which are going to represent the net ID and which are going to represent the host ID. So for net ID, I'm using N to represent net ID. H is to represent host ID. So in class A, 1 net ID, like 1 octet for net ID and 3 octet to represent host IDs. For class B, 2 octets to represent net ID and 2 octets to represent host ID. And in class C, there are 3 octets to represent net ID and 1 octet to represent host ID. In class D, all 4 are represent or vacant to represent the net ID. And class E, we say it is there for the special purposes and which we are not going to describe. Even I haven't searched about these class E IP addresses. So when in our syllabus, we are going to discuss about these 3 classes. Right? මේ තුන්දෙනාත් එක්ක තමයි වැඩිපුරම වැඩ කරන්නේ. Right? A, B, and C. But you should know there is something called D and E. Now I'm going to show you like these classes are having the ranges, right? ඒ කියන්නේ මේ IP address වලට class එක අඳුන ගන්න තියෙන කියන්නේ class එකකට අයිතිද කියලා අඳුන ගන්න තියෙන එක fact එකක්, එක සාධකයක් තමයි මේ IP address එකේ පටන් ගන්න first octet එකේ value එක. Right? ඒ value එක කොහොමද හැදිලා තියෙන්නේ කියන එක මම දැන් කියලා දෙනවා. ඒ වගේම තමයි ඕගොල්ලන්ගෙන් ඇහුවොත් ප්‍රශ්නයක් විදිහට is this particular IP address belongs to a class or not කියලා you have to consider 2 factors. First factor is like if it is going to be class A in the network ID or in the net ID, not the network ID, in the net ID there should be only 8 bits. මොකද දැන් මේ මෙතන තියෙන්නේ octets ටික. Right? Alright. මෙතන මගේ අතින් ලියවිච්ච නැති කොටසක් තියෙනවා මේ මේක octets කියලා මාක් කරගන්න. Right? This is the first octet. මාත් එක්කම ලියා ගන්න. This is the second octet. This is the third octet. And this is the fourth octet. Right? So if any IP address is going to be qualified as a class A address, then it should have 8 bits in its net ID. Net ID එකේ bit 8ක් තියෙන්නත් ඕනේ. And it should be in the given decimal value range for the first octet. පළවෙනි octet එකේ දීලා තියෙන range එකේ වෙන්නත් ඕනේ. Right? And I want you to write the ranges as well at the left hand side. Right? So මේ class A එක ගාව ලියා ගන්න 0-127. Class B range 128, 191. Class C range 192, 223. Class D 224, 239. Class E 240, 255. Right? So that means a value inside or like a value in a dotted decimal notation can be vary from 0 to 255. So 0 is going to be the lowest value. 255 is going to be the biggest value that a dotted decimal notation can have. It's better we write those 2 factors and have some examples as well, right? So here I'm writing the 2 factors to be classified in a class, right? So write it like this. You can start writing with me. sorry, exact, not the exact amount, the relevant amount. Right, those two factors should be there. If an IP address to be classified in a class, it should start with relevant decimal range. It should contain relevant amount of host bits or net bits. කොහොමද අපි relevant amount of host bits and net bits හොයාගන්නේ? මේ උඩ තියෙන පොඩි sketch එකකින් ඔයාලට හොයාගන්න පුළුවන් ඒක. right. දැන් ඕගොල්ලෝ sketch එක ඇඳන් තියෙන නිසා මම මෙන්න මෙහෙම ප්‍රශ්නයක් අහුවොත්. මම ප්‍රශ්නේ මෙතන ලියන්නම්. right. බලන්න මේ ප්‍රශ්නෙට උත්තර දී ගන්න පුළුවන්ද කියලා. ඔයගලගේ වගුව පාවිච්චි කරලා දැන් අපි පොඩ්ඩකට උඩින් හදපු sketch එක පාවිච්චි කරලා මේකට උත්තරේ කියන්න පුළුවන්. So the address I was given is 200.32.54.16. So 200 belongs to which group? To this particular range. And it says if it is to be qualified as a class C, you should have a net ID which spread over first three octets. So first spreading over first three octet means you are having 8 bits over here and 8 bits over here and 8 bits over here. So that means net ID contains 24 bits. So that is why we can determine it as a class full address. Now here I'm going to introduce you the CIDR notification. Right now CIDR notification is a way of giving the details about how many bits are there inside an IP address, right? So This is how we are going to write a CIDR notification. So CIDR notification is written like this. So if I take the very previous example, the one which is at the top, 232.54.16, I can write that particular example using the CIDR in a way like this. Right? So this is what you call CIDR notification. And now you can guess what 24 is. Neither. And this particular number, this represent how many bits are there in the net ID. Right? So this is what you call CIDR notification. Right? එතකොට මෙතනින් කියනවා how many bits are there in the net ID. So if you are given an IP address with the CIDR notification, you can straight away tell whether it is a class full or a classless, and if it is a class full, what is the class? හරි. එහෙනම් මට ටක් ගාලා මේ පහළ ලියන IP addresses ටික class full ද classless ද කියලා clear කරන්නත් ඕනේ, කියන්නත් ඕනේ. Then after class full නම් මොකක්ද class එක කියලා කියන්නත් ඕනේ. Right. I'm going to give you some CIDR notifications. මට ඔයගොල්ලෝ chat එකේ උත්තර ටික එව්වත් ඇති. yeah මිහින් දැන් මං ඇඳලා තියෙන ස්කෙච් එකේ host කැලලට තියෙන්නේ bits 8යි. මොකද ස්කෙච් එකේ කතා කරලා තියෙන්නේ octets වලට සම්බන්ධයෙන්. හැබැයි හැම වෙලාවෙම host එකට 8ක් තියෙනවා කියලා කියන්න බෑ. මගේ අපි ඇඳලා තියෙන ස්කෙච් එකේ හැටියට class full addresses වල තියෙන්නේ 8 ගුණාකාර තමයි. ඔව් ඒක හොයන විදිහ මේ මම මේ කියලා දීපු CIDR notification එක ක්‍රමයක්. තව ක්‍රම තියෙනවා. We'll discuss it later. ඉස්සරහට අපි කතා කරනවා ගැන. From hereafter, I'm going to tell you how these classes are going to have their ranges in this particular manner. Right? ඒ කියන්නේ මේ බිංදුව 127 උනේ කොහොමද? 128 191 උනේ කොහොමද? 192 223 උනේ කොහොමද? ඔය කියන එක ඒ කියන්නේ ওই විදිහට ඉස්සරහා අංකෙ වෙන් උනේ කොහොමද කියන එක ගැන තමයි මම දැන් කතා කරන්න හදන්නේ. Right? දැන් මේ වැඩේට ඔයගලන්ට මම අර කලින් කිව්වාගේ කොලේ හරස් හතට පාවිච්චි කරන්න ටිකක් ඉඩ යන වැඩක් මේක. Right? So your first column is the class. So I'm taking class A. And first octet, I'm going to expand the first octet, right? So why I'm expanding first octet is to give you the nature. Now, when it comes to the first octet of class A, there is the most significant bit of the octet is going to act as a leading bit. Leading bit එකක් කියලා කියන්නේ change වෙන්නේ නැති කෙනෙක්. So first octet is having 8 bits. So the most significant bit is going to be a constant. So it is going to be 0 always. And other 7 zeros and other 7 positions actually can be changed as it want, right? So other 7 zeros are acting like this. So the least value is going to be a 0 and the most value are going to indicate when it comes all ones. Then may ඉස්සරහා bit එක මම කිව්වා leading bit එක කියලා, right? So this is called the leading bit. එයා change කරන්න බෑ. So from this it's going to indicate a 0. right ළමයි තප්පරයක් ඉන්න බෝඩ් එක රෙස්පොන්ඩ් කරන්න නැතුව ගියා. right මේක equal වෙනවා 0ට. So the most value is first bit is going to be the most significant bit is going to be a 0 and the rest is going to be ones. මෙහෙම දැම්මම තමයි උපරිමාගය අපිට හම්බෙන්නේ. So that indicates 127. This indicates 127. Now that is how the class A is having zeros, the range which is from 0 to 127. තේරුණාද? Right. So if you consider the other octets, the second octet, so it can have all 8 bits as zeros, which gives you a 0, and also as the maximum value as all ones for all the bits, so which is going to represent 255. Right. So likewise, the third and the fourth contains the same value from 0 to 255, and this is from 0 to 255, like it happens in the second bit. Right. So I'm going for the class B. So in class B, there are 2 leading bits. ඒ කියන්නේ දෙන්නෙක් වෙනස් වෙන්නේ. So those 2 leading bits are 1 and a 0. මේ 1 and 0 කොයි වෙලාවෙත් ඔය විදිහම තමයි. class B එකේ. Right? And others will be different. Right? So other 6 bits can have 6 zeros as the least value, which indicates 128. Right? And as the most value, 1 and 0 will be there, and 6 ones will be there as well. So 1, 0 is not going to change. And others are going to be in ones. And that will give you 191 as the most value in the class B. Right? So rest of the octets again act as the very same way as it act in the previous manner. So they are 0 to 255, the range is. So that gives you the range of class B from 128 to 191. So class C is going to be like this. It has 3 leading bits, 1, 1, and a 0 is going to be leading bits. So the rest of the bits can be changed. So the least value is going to indicate by this, and which has the value equals to 192, and the most value is going to be all ones, which gives you the value as 223. So these things are going to be the same. So that gives you the range of class C from 192 to 223. So when it comes to the class D is having 4 leading bits. D එකයි අරගෙන ඇඳගෙන යන්න පුළුවන්. So it is having 4 leading bits, 1110. So which gives you 4 zeros that can be changed, which gives you the total as 224. And the most value 1110 is not changed. Then 4 ones are there, which gives you the total as 239. So here it is the same, 0 to 255, 0 to 255, and 0 to 255. So that gives you the range for class D from 224 to 239. So the final one, class E, it's also having 4 leading bits, 4 දෙනයි වෙනස් වෙන්නේ නැත්තේ, and those are going to represent as 1, 1, 1, and 1. කලින් එකේ තිබ්බේ D එකේ තිබ්බේ 1110 මෙයා ඉන්නේ 1111 and other bits can be stays as 0 which gives you 240 and the most value is going to be 1111 and 4 ones. Which is going to give you 255. So rest is going to be the very same 0 to 255. 0 to 255. Right, people, that's the end of that thing. So if you got it correctly, you can exit from the session, right? And remember, next week we are going to have the class from 3:30 to 5:30, right? So I'll put the message to the group as well, right? Please remember it and please take place, right? All right, people, if you're done with this, you can exit. Thank you very much and have a very nice weekend. Not a weekend, actually, neither. Right. Have a good night, people. You can exit if you are done with this. Right. Good night, Dua. Right. Charuba, good night. Right. Okay, Minidi, good night.